Hello students, welcome once again to our channel Physi Dive, and this is your teacher Alexi Rajan. Today also we are going with the introduction part of the third chapter of class 11 Ncert, that is motion in a straight line. So without wasting time, let's dive in straight to the class. So my next point is that frame of reference. For studying this distance and displacement, we need to study about this frame of reference and the origin is very, very important. Then only we can explain the position change, explain the path covered and all. So what is this frame of reference and origin in the case of motion in a straight line? So let us see. So I'm just taking a number line here. Okay, just let this be 1, let this be 1, let this be 2, 3, 4, like that, and let this be -1, -2, -3, like that. Okay, I'm just taking this number line because I want to study about the movement in a straight line. Okay, let us assume that a person is standing here at 0 or we at 0. Okay, fine. And I am saying that this person is moving from this 0 to 3. Geographically, this one is north, this one is south, this one is east, and this one is west. Okay, fine. Let us say that the person moves 5 meters to the east. Okay, so let this be the fifth point. Okay, now the person is here. The person is here. Okay, fine. And now, after some time, I'm saying that this person is again moving 3 meters to the west. So where is he now? So you can see the person starts from 0 and then he reaches to this particular point 5 and then he moves back or west, because east and west they are opposite. So we can say to 3 meters back. Okay, 5 minus 3, now he is somewhere here, that is at position 2. Now you itself say what is the path covered and what is the position change. The path covered is a total distance travel, that is you add both and you can say it is 8 meters, right? But what is the position? What is the position change here? You can see initially is at 0 and finally is at 2, that is the position change is 2. But this is the displacement. So position change is nothing but the displacement, and here 8 meters is the distance. But here the thing is that you are calculating all these calculations with respect to this particular point of origin, right? If the person is starting from 0, then only you can just calculate, or you are just calculating with respect to a position or a point, and we call it as what? An origin. This particular point or place is otherwise known as what? Frame of reference. So you need a frame of reference to calculate the movement of a particle, or to calculate the velocity or displacement, distance, velocity, speed, acceleration, and all the attribute this particular with respect, or this particular point or place with respect to which you are calculating this is values, is known as what? The frame of reference. And this is the origin, where it starts. Origin is a point from where you start your movement, and we call it as what? The origin. And it's purely your choice to take the origin. It's not like you always want to start it from 0. No, you can also start it from 4. You can say the person starts from 4, that particular, if you're calculating that particular point 4, then you can say that thing, okay, let it be. It's up to your choice, but you should calculate in such a way that your origin should be taken into consideration. You can also start it from 0, you can also start from 1, 2, 3, 4, it's up to you. But make sure that you must take the origin into consideration. So that's all about the frame of reference and the origin. And while studying, one more thing, while studying the frame of reference, you need to study about a very important topic, that is the coordinate system. While studying about the frame of reference, this coordinate system is very important. Otherwise, this frame of reference can be in another name, that is a coordinate system. The first and foremost coordinate system is a Cartesian coordinate system. Cartesian coordinate system is nothing but it is a xy axis, xyz axis. So this is a plane, so that's why we can all we are taking like this. Okay, let it be z axis. So from this O origin, we can say that is what axis is there. X axis is there, y axis is there, z axis is there. There is no particular rule that I should always take the horizontal as x and vertical as y. But one thing is there, you can also take this as y. Okay, I should put the arrow marks there, y, and this as the x also. But z will be, positive z will be having a particular direction. You can take this x and y according to your choice, but z will be according to Maxwell's screw rules or right hand screw rule. That means if x and y is like this, then I should take a right hand screw and then I will just rotate it from x to y, rotate it from x to y. Then a right hand screw. Right hand screw means it is a type of screw in which you turn the screw's head to rightwards, then it will just pierce in. It will pierce in. Such type of screw is known as what? Right hand screw. And if you are turning a right hand screw to the left side, that is from x to y, then obviously the screw will come outside. If I am having a right hand screw, imagine that an ant is moving. Okay, this is an ant. This ant is moving through a thread, through a wire. So the only direction the ant can move is, so you can explain the movement of this particular ant with respect to a single coordinate or single axis, one directional motion in a Cartesian coordinate. So just imagine that if I want to find out the same ant's movement on a paper, the movement of ant is on a paper. This ant is moving along this particular area, this paper. Okay, so first it moves like this, let it move like this, move like this, move like this, move like this. Okay, different position, A, B, C, D, like that, different position. So how can I find out the movement of ant on a paper or on a plane? So I will take the Cartesian coordinate, and the Cartesian coordinate will consist of two axes, that is x and y. Just imagine that the ant is at this particular position P. Then I can find out the position of P or position of ant by using a Cartesian coordinate with two dimension or in a plane as, let this be, okay, let this be the position, let this be x and let this be y. Then the position of that ant will be P, x, y. So at that particular point, you can find out the ant. So that's all about the two-dimensional motion in a Cartesian coordinate.
Now we have seen one-dimensional and two-dimensional coordinate system, right? Now the major thing or the major portion is that the third-dimensional or three-dimensional coordinate system in Cartesian coordinate. So here, what is the importance of three-dimensional coordinate system? For example, if I'm considering a bird here, I need to find out the position of this particular bird. So I need to know about its, if I'm just taking this as an origin, this point as an origin, then I need to calculate from how much distance the bird is placed to the x-axis and how much distance is its y-axis. Okay. So here it is a y-axis, and one more attribute is there, that is how much this is displaced in its z-axis. So here is the z-axis. So x, y, z-axis is required to find out the position of the bird. So here three coordinates are required to find the position of an object, and we call it as what? A three-dimensional system. And here we are using the Cartesian coordinate, so we call it as what? Three-dimensional Cartesian coordinate. So this is about the three-dimensional Cartesian coordinate. If I want to find out the position of an object, if three coordinates are three axes are required, three coordinates are required, then we call it as a three-dimensional coordinate system. So that's all about the 1D, 2D and 3D coordinates. It's nothing but in the case of a coordinate system, two more coordinates are there, that is a cylindrical and spherical coordinate system. Why we are using this cylindrical and spherical coordinate system? So now in small classes there is we are not touching the spherical and cylindrical coordinate system, but in higher standards the major thing is that for complex systems, we need to use a cylindrical and spherical coordinate system. It is not possible to calculate the position, momentum, and other attributes of a system by using a Cartesian coordinate system. So there, the importance of this cylindrical as well as spherical coordinate system comes into play. So that's all. And now we are diving straight to the next topic, that is speed and velocity. We need to find out the physics behind speed and velocity. So first we are taking the first term, that is a speed. What is the physics behind speed? What is the definition of speed? Speed, from our small class itself we had studied. Speed, it is nothing but the distance by time. Or what is distance? The path covered. Path covered by time. Path covered. Here we all know that path covered, there is no specified direction, or direction have nothing to do with the path covered or distance. So we call it as what? A scalar quantity. So speed is a scalar quantity. Why? Because there is no direction comes into play. So that's why it's a scalar quantity. What is the SI unit of speed? That is, SI unit of this distance is meter. So meter per second, or meter second inverse. Velocity have a specified importance in physics world. So velocity is a displacement by time. So displacement is what? Change in position. So change in position by time. So how much an object is changing its position with respect to a time, it gives you the velocity of that particular body. So here velocity have a very important importance in physical world. Why? Because involvement of direction is clearly mentioned there. So here we can say that velocity is what quantity? It is a vector quantity. Why? Because both magnitude and directions are there for velocity. So velocity is a vector quantity. So what is a SI unit there? SI unit of displacement is what? Meter. And SI unit of time is seconds. So meter second inverse. Same as that of speed. You will get same SI unit there. Okay, now one more very important difference between speed and velocity is that speed will always have a positive value, whereas velocity will have three values, that is a positive value, zero value, and the third one is a negative value. What is that? Zero value, negative value, positive value, and all. Just imagine that there is a coordinate. So I can say that here is Meena. So she is standing here. Okay, now from this origin she is going or moving 2 meters to the east. Okay, now she is somewhere here. So what is her velocity? So what is her displacement first? So it is 2 meters. So she had displaced her position from 0 to 2. So 2 meters, and that is positive direction. Why? Because conventionally I am taking the right side of my origin as positive. So positive 2 meters. Now I am saying that Meena again comes back to that particular origin. Now she is at the origin. So what is her displacement? Initial point, final point, both are same. So displacement is 0 because there is no position change there. Now she is not stopping there. Again she is moving 2 meters to the east from the origin. Now she is somewhere here. Now what is a position change? Position change only depends on the initial and final position. And now from the origin to this particular point. So here the value is 2 meters again, but the direction is in the negative direction, so negative 2 meters. Here you can see the displacement is positive 2, 0 and 3 minus 2 meters there. And if I am calculating the velocity with the corresponding displacement, then I'll get a positive value first, next 0 value, and the third one we'll get a negative velocity there. So that's why I said displacement will have 3 values: positive value, 0 and negative value. Whereas speed, it is a definition. By the definition we know that speed is what? Distance by time. Distance is what? Path covered. Path covered will always be positive. Path covered is 0 means there is no movement. It is at stagnant position. So there is no importance in speed, right? Okay, fine. So it is always having a positive value.
So that's all for today's class. I hope that you got the points. Now we need your support in the form of your like, share, comment and subscription. So we'll meet in the next class with new topics. So goodbye and have a nice day.